Tonight's lesson is about factoring trinomials. The first section is trinomials that we've already done, so we're just going to notice the pattern again and then move on to 8.4. So hopefully you remember from the last unit that we first started taking those squares of x plus 2, and then we had x plus 5, and we figured out that this gave us x squared. We had 2x, 5x there, and then 10. And then we talked again, after we got this expanded form, how we could move backwards. If I gave you x squared plus 7x plus 10, how could we figure out what the two binomials were that multiplied together to get that? So we quickly noticed a pattern, and this was the pattern, that the number in the middle gave us the sum of these two numbers in our binomial, 2 and 5 in this case, and that the number on the end was the product of them, because we can see right here in that box, we had to multiply those two numbers together. So now we're going to take this a step further. If you noticed with all the ones that we did in the last unit, this number in front of x squared was just a 1. It's a little harder when it's not 1. That's what the focus of 8.4 is all about. So before we move on to 8.4, I just want to talk about a problem that you might see on a test or a quiz. But it's basically stuff that we spent the last unit doing. So take a second and look over this. It tells us to factor something, which we already know how to do. We want two numbers that add to make 11, and these same two numbers have to multiply to make 24. So I'm guessing 3 and 8 popped into your mind. And if they didn't, this is how they got it down here. And then once they did that, they said, well, do I get the same things when I plug in numbers for n in the expanded form and then in the factored form? And this is something we've already done, but you might be asked a question that's stated like this. To factor, and then show that the original polynomial, so this is your expanded form, and the factored form have the same value for just any numbers that they gave you. And in this case, they gave you 0, 1, 2, 3, and 4. So if you have questions about that, I'll answer them tomorrow, but hopefully everybody knows what they're doing with that. So let's move on to section 8.4, factoring trinomials still, but this time we're going to have a number in front of x squared, and that kind of changes everything. So let's for a second remember the old way and see if we can draw connections to the new way, the problem on the right. So the first one, same problem as before. We had x plus 2, and then x plus 5. And when we multiplied those in, same square that I drew on the first slide, we have 5x here and then 10. We had these two numbers right here add up to the number in the middle. And then this number here on the end was the product of the two coefficients, or of the two constants. So this diamond thing is going to help us with the other problems that we do from now on. And in this diamond, there's 4 parts to it. And we're going to basically play like a logic game. Can you figure out what numbers work here? So in the top part of your diamond, we have two numbers that add together to get whatever number goes up here, and then multiply to get whatever number goes down there. And your two numbers go in the left and in the right. So the diamond problem for this one, we would want two numbers that add to make 7, and these same two numbers have to multiply to make 10. This is just a way to help us think about these problems. We could have just as easily looked at the actual trinomial and said those exact same things. But then the two numbers that we get, the 2 and the 5, we're going to write on either edge of the diamond. And again, this will come in more handy once we do the more difficult ones. So now let's see if we can draw any connections to one that has a different number in front of x squared, like this 2. So let's take these two terms right here and put them in our box, just like we did with the other ones. So we'd have 2x plus 2, and then x plus 5. We multiply in the box. This first one I get 2x squared, and then right below it I get 2x. To the right of that I would get 10x, and then I would end up with 10 again. So this is what makes this so different. We have these numbers in the middle again that sum up to our number in the middle, and this number in this box that gets here. But how can we figure these numbers out? So the trick to this one is realizing that the addition part is still exactly the same. We want two numbers to add to this number in the middle, this 12. And if you look in our box, the two numbers that we picked to do that are 2 and then 10. Remember, there's tons of other ways that we could add up to 12, but we picked 2 and 10. So again, if you multiply 2 times 10, you don't end up with 10, what we got here. We need to remember that there is a number in front of x squared, and that changes everything. So instead of just multiplying to make the number on the end, we want it to multiply to make the number in the front, so in this case 2, times the number on the end. Those two multiplied together. And if you look, the numbers that we have, the 2 and the 10, do that. So how can we just throw in a new rule? If we go to this next slide, it works for the one that we just did. So the easy one, where we can just stop and think about what's going on. So we have our diagonal again. We want two numbers that multiply to make 1 times 10. In this case, there was a 1 here, times a 10 here. So 1 times 10 gives us the 10 in this box that we want. And then those same two numbers still have to add to the number in the middle, which is this 7 here. And we can see that 2 and 5 definitely do that. So this is confusing once we start doing some problems. Hopefully this will make a little more sense. But here are the rules that we're going to follow. So this is the form that we're factoring. ax squared plus bx plus c. The a always hangs out with x squared, the b has an x on it, and the c is just a plain old number. So the first thing you're going to do is multiply a times c. That is going to give us the diamond puzzle product. So your product goes down here, a times c is going to go here. B is always the diamond puzzle sum. So whatever your B is going to go there. And then you're going to look for your two numbers. Solve the diamond. And when you do that, you place those values here. So this is diamond solution number 1, and this is diamond solution number 2. That holds true to those two things. Adds to make B and multiplies to make AC. And once we've put it into this matrix right here, step number 5 is factoring out the dimensions. So we first look here. What do they have in common? And we pull it out. And then we look here. Same thing. What do they have in common? And we pull it out. And then we go up and down. What do these guys have in common? And then what do these guys have in common? So again, might be confusing, but once we do some problems, you'll get the hang of it. So let's try one. If I want to factor 3n squared plus 11n minus 4. So the first thing I want to do is fill out my diamond. Two things have to add to b, or the number in the middle, which is 11. And those same two things have to multiply to make AC, which in this case is 3 times negative 4. Multiply those together, we get negative 12. So then you have to sit and think of the numbers that do this, just like we did for the easier ones before. What two numbers multiply to make negative 12 and add to make 11? So the numbers that I'm popping into my mind are 12 and 1. And I want to make the 1 negative in order to add to make positive 11. So then we go and we fill out our matrix. And we fill it out just like it has it up here. So ax squared is your first number here. 3n squared. And then the c is the other easy part. That's just the number on the end. Goes down here. And then our diamond solutions, this negative 1 and 12, go in either of these spots. And it doesn't matter which one you put it in, you're still going to get the same answer. And you always have to remember to put your x or your variable, whatever it is, on the end of those numbers. Because remember, what we did here is we are splitting up into like 5x plus 2x, which gave us the 7x. So this should be 12n in this case, and then negative 1n. And then we go through and we factor out each row. So let's just look at this first row here. What do 3n squared and negative n have in common? Number-wise, they don't have anything in common, but they each have an n. So I'm going to pull that out. And then 12n and negative 4, they have a 4 in common, and it's a positive 4. And guess what? This is one of my terms here. N plus 4. And then you do the same thing top to bottom. What do 3n squared and 12n have in common? Well, they both have a 3, then they both have one n that I can take out. And then the next one, negative 1n and 4. They both have a negative, but number-wise, they don't have any numbers in common, so I have to pull out a 1. And this right here is my other term. And we can always check this to make sure that it's right by double distributing. If we say this is our answer, we should be able to multiply it back together to get the thing we started with. So if we do that, we get 3n squared minus n plus 12n minus 4. And you can see if you combine these two like terms right here, you will end up with positive 11 n's, which is what our problem gave us in the beginning. So let's do one more together. So I have 4x squared minus 10x minus 15. So again, the first thing we need to do is fill out our diamond. So I want two numbers that add to make my b, which is negative 10. And these same two numbers have to multiply to make 4 times negative 15, or AC. And that is negative 60. So then we sit and think, what two numbers do this? And after you've racked your brain enough, you should figure out that there are no combinations that do this, that add to make negative 10 and multiply to make negative 60. So this is a super easy problem once you figure that out. You just write not factorable. And move on. So let's try this next one. This one is factorable. So if we want, and it's only factorable if we make one little modification. So go ahead and make this a positive 3 right here, and that'll make our life a lot easier. So again, we want to fill out our diamond. We want two numbers that have to add together to make 7. And these same two numbers have to multiply to make 2 times positive 3 now, and that's 6. So what two numbers multiply to make 6 and add to make 7? They have to be 1 and 6, both positive. So once we know that, we can fill out our whole diamond table. Remember that this first thing goes in the first box, and then the last thing, positive 3, goes in the last box. And then you can split up this 1 and 6 however you want, as long as you give it a variable, because that's 1x plus 6x, that gives us that 7x. So 1x, let's put here, and let's put 6x there. Remember, it doesn't matter which way you put it. And then you factor out along the rows and then along the columns. So if I just factor along the rows here, the only thing those two terms have in common is an x. And then the only thing these two have in common is a 3. So we have x plus 3. And do the same thing this way. We can pull out a 2x. And these ones don't have anything in common, so you have to pull out a 1. And there is your other term. This is it for this video. I'm going to have one more where I show you this factoring by grouping and do a couple more examples for you. So if you don't need the more examples, feel free not to watch it, but make sure you watch the factoring by grouping part.